So if everyone can find your seat, I think we're going to start pretty soon. And once again, this event is a webcast live, and those will be recorded. The recording is going to be placed on the program website. All the presentations will also be uploaded to the program website. And of course, all the pictures we took from this event will also be uploaded. Once again, the restrooms and the drinking fountain are past the green chandelier. In case of a fire drill or a real fire or real anything, everybody calmly take the stairs down to the first floor and exit the building to meet in the Cesar Chavez Park. So this morning, we heard a lot of comments and the discussions from yesterday about scaling up. What's the best strategy? What's the best time? What's the most cost-effective way? What's the way that the small transit agencies can utilize? So hopefully that for today's panels, we can provide further insight to those questions. So we still have 3 more panels for today's discussion. Panel 4 is going to be discussing infrastructure scaling up. Panel 5 is going to, we are going to hear utilities to provide their transportation electrification program update. And also session 6 is going to provide a lot of opportunities for workforce development and training, and also green job creations, and also technology troubleshooting. So without further ado, I'm going to hand this over to Kylie. Thanks.
Thanks. So I'm Kylie McCord. I am a project manager for ZEB transition planning and bus deployment projects for the Center for Transportation and the Environment. One of the common themes that we heard a lot yesterday was that a demonstration project for electric buses is easy relative to transitioning that out to your full scale for either a depot or a fleet. So that's really what we want to address today with our panel. We've got Roland Cordero with Foothill Transit, Damon Hanneman with Southern California Edison, Kevin Christopher with ChargePoint, and Lars Peters with EVgo. And we'll go through really more case studies looking at some of the work that they've done and the lessons learned through those processes. Once we go through the panelists, then we'll take questions. So, Roland?
Good morning. So I'm going to share our experience with our previous purchases of electric buses and how we're trying to move forward to 100% fleet electrification. Our executive board approved our initiative to go 100% electric by 2030. Currently, we have a fleet of 373 buses operating out of 2 yards, Pomona Yard and Arcadia Yard. Out of those 373 buses, we have a fleet of 30 battery electric buses, a combination of 35-foot-long fast charge, short-range buses with a range of 35 miles, 2 40-foot fast charge, also with a range of 35 miles, and over a year ago, we acquired 14 40-foot extended range E2 440-mile kilowatt, approximately 251 miles of range from Proterra. The 251 is a nominal range. Definition of that is up to you, how you want to perceive that nominal range of 251. With our experience with fast charge buses, especially the ones that are en route charge, those buses cannot be deployed in other areas of your service where you don't have an en route charging station. The extended range buses, we are currently working with Proterra in terms of design and installation of somewhat I would call an overhead charging station for those 14 buses in partnership with Southern California Edison. I say it's somewhat of an overhead. The design calls for laying out all the plug-in chargers at 2 bus parking stalls next to the 14 parking stalls where the buses are going to be parked. We're going to have an overhead structure which will house the dispensers, and the plug-in chargers will be retractable over a hose reel, so we can plug the buses from using a plug-in charging system. So moving forward with our board's approval of our initiative to go 100% by 2030, we found that this whole project, electrifying your fleet of 337 buses, is a very daunting task. It's a very complicated process. Moving from 2 to 3 or 4 buses, that's a little bit easier to manage, but when you want to change your whole entire fleet, that's a different issue. Switching over to 100% impacts your whole operations, your planning, route planning, operations department, finance, trying to find the capital to fund the project, your facilities, getting involved with the construction and the design of the yard, your marketing also in terms of creating marketing programs for that program. So what did we do in order to address that project? We issued an RFP for a consulting firm. We hired Burns & McDonnell. We had 4 proposals. We evaluated proposals based on their experience and ability to deliver the project, as well as the proposed costs. The scope of work that was presented to us by Burns & McDonnell is a very comprehensive proposal in terms of it lays out everything that we need to design this whole implementation system. First part is route planning, power infrastructure forecast to 2030. What Burns & McDonnell's team is doing right now is analyzing every block in our system, looking at traffic conditions for each block, passenger load, weather, and topography, because each block is going to be different. You're going to come up with a different kilowatt of energy to operate that block. So based on their initial analysis, my conversation with them last week, they said that their analysis shows that with today's technology, we can only electrify 60% of our routes. So that's still got 40% to work with, but based on today's technology. I mentioned that each route would always give you will be able to not get the same mileages off of a bus. We're taking over a service with one of our member cities, and we're taking over 2 routes. It's a circular route within the city itself. And they're pretty much the same in terms of mileage. The only difference is the topography of the route. There's a hill climb as part of the service. And we found out that on one route, we can travel about 160 miles in the same bus, and on another route, about 153. Main reason being is there's a hill climb that's part of the route, and the hill climb is not a perfect cone. So on one side, it's a steeper climb versus on the other side. So if you do some range testing and you think that if you test on one block or one route that you're going to get a certain amount of mileage, I think you need to be a little bit more detailed in terms of testing. Charging equipment, market and specification analysis. Burns & McDonnell issued an RFI to all OEMs, bus manufacturers, as well as charging equipment manufacturers. They requested a whole bunch of information, which they used to analyze and assess what companies can provide us with the equipment that we need to fully electrify our fleet, the type of charging equipment, which companies can meet our demand, warranty, as well as meet the equipment specifications. Depot yard layout, development and assessment. Both of our facilities we have space constraints. The Pomona yard, we have 150 buses. The Arcadia yard, we have 223 buses. We have very limited parking space. Part of the analysis that Burns and McDonnell is preparing for us is looking at how we can still able to park those number of buses in a yard, and at the same time developing or designing how we can lay out charging equipment, installation of solar panels, and everything that's related to electrifying our fleet. The issue that we have is as we progress to acquiring additional electric buses throughout the years, we're still going to have some CNG buses that we haven't retired. And we're still going to have that CNG fueling station on our facility, and you have to figure out how you're going to take that equipment out while you're bringing in your new charging equipment, and how do you plan that out? On-site transformer, electrical infrastructure. They've been in contact with Southern California Edison, discussing what type of infrastructure do we need to meet the 2030 goal. Looking at the amount of energy that we need to charge our buses. We deliver about 1.5 million miles of service each month. And if you look at the average efficiency of an electric bus, let's say 2 kilowatts per mile, kind of figure it's going to require about 3 million kilowatts of energy to charge your buses or to put your buses in service. That's a large amount of power that you need. So there's a lot of conversation with Southern California Edison. They partnered with us in terms of designing infrastructure for our 14 extended range buses at Arcadia. They're also looking at how we can move forward and meet that need up to 2030. Utility grid infrastructure analysis and sufficiency kind of ties in with on-site transformer electrical infrastructure. Renewable energy analysis and backup power. They are looking at a combination of solar panels over our overhead structure, as well as offsite, as I mentioned yesterday, offsite solar energy purchase, as well as a possible battery electric storage in the facility. Again, you got to look at all the equipment that you're bringing into your facility. With space constraints, you still have to be able to park your buses in the yard and figure out how you're going to bring in all that equipment necessary. One of the things that we've discussed with them is having the equipment installed on a overhead structure so that we don't take too much land space. They're also, in terms of backup power, in their analysis, it seemed they found out that the substation that's servicing both of our yards, I think they haven't had much of an issue in terms of losing or shutting down the power. So the thing that we're looking at is if you're looking for a backup power, let's say there's a natural disaster and we lose all of our electricity, do you really need to put 100% of your service for that day? Maybe 50%. So the approach is how much energy do we need to provide or to deploy 50% of our service during a natural disaster? The project is scheduled for completion July or August, so I'm looking forward to getting the results of this study. And I think this will be a good reference material for some transit agencies that are looking into electrifying your fleet 100%. You know, it's not a one-size-fits-all, but I think it would be a good reference material. So just to give you an idea, this is a layout of our Arcadia yard. Our approach to building infrastructure is to avoid having construction on an annual basis. So the brown areas and the green, the yellow, orange, kind of orange areas, those are where our buses are parked. The blue section is where we're going to install an overhead charging station for our first 14 extended range buses. The plan is, our fleet plan calls for acquiring 30 buses every year. So in order to efficiently have a very efficient design process and installation process, we're going to install charging equipment on a phased-out system. So our approach is to build a charging station for 5 years out of purchase. So instead of building out for 30 buses, the first construction schedule would be for 150 buses. So you can continue your bus procurement, and as the buses arrive, you already have the infrastructure in place. Infrastructure is a very important part of this project. I mean, you can't have electric buses operating the service if you don't have a way to charge or fuel the buses. So our design is to be on a 5-year process. Let's see. So the same system is what we're looking at for our Pomona yard. So just look at your system and see how it's going to work out for you. This is I think, as far as I'm concerned, this is a good design, and hopefully works out for us. That concludes my presentation. Thank you.
You know what, I might actually I'm going to leverage his, it's the same thing. Could you go back there? Yeah. I'm going to use your site plan. So, good morning. My name is Damon Hanneman. I work for Southern California Edison. I work with the accounts, so Foothill Transit is one of my accounts. I also have other transit agencies like Long Beach Transit and Santa Monica Big Blue Bus. I also handle the Port of Long Beach, so I have all the major terminals in the port, which we're doing a lot of electrification down there also, and I've had experience with some of the projects that we've done down there and electrifying their operations. The Foothill Transit project is part of our Charge Ready, what we call our priority review projects. So this first 14 is just the beginning. We have a program that I'll talk about later on that we will call upon to expand the infrastructure at Foothill Transit and then also other locations within our service territory. But specifically, I just want to talk about planning and working with your utilities, because I know not everybody here is a customer of Southern California Edison, but you do have an electric utility that services your facilities now. It is key that you approach your utility at the very beginning stages of these projects. You have to have someone come out, talk about what's serving you now, talk about some of the high-level plans that you have, even though if nothing's in concrete, at least have that conversation with them about the high-level plans of what you are going to adopt in the future. Is there board approval for a certain amount? What's that adoption rate? We work with Foothill Transit on how many they're going to be converting over the next 12 years to 2030. So we have a plan in order to accommodate that growth. Now, in the pilot program and what we're doing at some of the other customers and other sites is that we know that we only have 14 now existing buses. We know there's going to be growth. But what we can do is in our programs is we're doing the infrastructure. Normally, it's the customer's responsibility to build the civil part of the infrastructure, the ducts and structures. And then it's the customer's responsibility to install a panel and then install all the infrastructure on the other side of the panel to get to the charging units. Edison is doing all of that work now in our programs. So we're doing all of the civil on the front side of the panel, all of the civil on the other side of the customer side of the panel. We're installing, well, not in this situation, we're installing a panel or disconnects for the charging units. So we're calling it make ready infrastructure. So we're making it ready for you to land your charging units that you would contract out with. But in this case, I'd just like to talk about when Burns McDonald came into this project, their design called for the area in yellow to be electrified on this map. Due to the fact that our existing infrastructure for the CNG, which is the bulk of the power that we provide to this site, we do power the compressed natural gas operations there. The bulk of that infrastructure is residing in the area between the yellow section and the pink building to the left, to the right. And it's a kind of a grayed out area. That's their wash facility, I believe? Yeah. Is there a laser? Yeah. I don't know if there was a laser on there or not. But right below in between the gray building and the pink building is our existing infrastructure. And they felt that we were going to just expand in that area and then feed the area in the yellow, assuming that's because Edison's already coming in from that location. Well, when we did our site visit, and I don't know if anybody was for the presentation with Simon yesterday, when Simon and I came out for the site visit with some of his team, we looked at the site and said, you know what, I think there's a better opportunity here to serve this and to expand. And we actually are now going to come off the property from the bottom or from the south. Along the wall, there's yellow along the right wall. So we're going to come in from a service, a whole other service that's not even feeding this facility now. We have a 16,000 volt system that is just immediately south of this property that we're going to tap into and leverage because we got capacity on that system. And it made sense. And we could come in along the wall outside the property and then cut into the property, bore in, and then essentially bore up to the area just north of the area in the blue. So why I'm bringing this up is that you've got to bring in the utility early because what you think might be the logical location might not be for the utility. It might be off another circuit. The circuit you're on might be constrained and there's just available capacity in the neighboring circuit or something of that nature, which was a situation for this project. So once we come in and bore, we're going to land all of our equipment. We're in discussions. We do this, so we're essentially the GC, I guess you would say, for this project, and we're coordinating with Proterra, their charging provider, to get all the equipment in the right area to make sure that we're meeting Proterra's needs. We're meeting Foothill Transit's needs, and then we're meeting our needs. And so it's a collaboration that we're having. It's ongoing. We have a call every week to discuss it. Things happen, changes come up, and we adjust. And now we're going into final plans and submitting for permits. We expect to break ground, I believe, in 2 months. And then we should be done. Once we start going, we'll be done pretty fast. And then it'll be Proterra's turn to then construct their equipment to then connect to the buses, which should be around June, I believe. But I really just wanted to bring up that situation. Engage the utilities early. It just makes sense. Utilities take a long time. We're not the quickest people in the world. But for this project, we were able to really jump in, make some changes, and make changes that we think will fit for growth of this site. So we will have infrastructure, and we're going to oversize the civil so we can bring in a larger conduit, a larger conductor. We're going to oversize the structure so we can bring in bigger transformers, and we're going to plan for adding extra space for maybe some capacitors or other things that we might need in the future in the area just north of the blue. So then we can expand all the way down south past the blue section into the brown section. And then potentially we might have enough capacity to go over into the other brown section. And that's that kind of future planning that we're having with Foothill Transit, that we're trying to create the smallest footprint possible on their site to meet their growth. We don't want to come in and reconstruct and do all new work again. We're trying to be smart about it, build the structures large enough now since we're there to accommodate future growth. And those are things that we're kind of doing at Southern California Edison right now. Yeah.
Hi, my name is Kevin Christopher. I'm a senior program manager at ChargePoint. My day-to-day job involves working on electric transportation, working with our partners on the vehicle manufacturing side, and also with our customers that are transit agencies. So what I decided to do today was really kind of build on Roland and Damon's point, just in terms of planning. So from a generic perspective, if you're looking at alternative fuels, if you're trying to move to lower no emissions, how do you go about that, and what are the steps you should consider first in your planning and development? So I've just got a couple of slides here I'll work through. And really, I think the most important thing is really acknowledge that when you're looking at battery electric buses in this case, or any type of alternative fuel, it really comes down to the ecosystem that you're working with. As you know, you have a pretty complicated situation happening not only at the site level with your operations, but planning, funding, the vehicle side, the charging side, the infrastructure component as well. So it's really about acknowledging all those components, but really starting from the first point, which really should be the vehicle operations piece and performing that route analysis that Roland made. Because if you come to ChargePoint or another manufacturer in the space and say, hey, I want to electrify my entire fleet, the first thing I'm going to ask you is, well, how are you planning on using your vehicles? What type of power do you need? in terms of the kilowatt hours on the battery side and how are you going to be using those vehicles in service, so we can then size the equipment needs. And then you can then have those conversations with the utility, Southern California Edison, PG&E in this case, in this territory. And there's a lot of objective parties that can help you with this piece. So taking a look at your current block schedules, how are you using your current vehicles, considering the new technology that's available in terms of battery electric buses on the vehicle side. I was trying to click through here. But once you understand, what your routes look like today, how do you do the stress testing? So is there an anomaly in terms of the topography, as Roland mentioned, or is there an issue maybe with climate? In other states that we work in, winter and cold is a huge issue, preconditioning the vehicles. So how do you identify, by route, by bus, what type of energy you're gonna need to be able to handle those existing routes? Then working with the vehicle manufacturers in terms of identifying your specifications for those vehicles as well, which then helps you work through the planning piece and, sorry. Don't want to click through. But essentially what this all ends up doing is getting you a nice picture of what you'll be considering in terms of the vehicle operations and the specifications, so you can then get to the system design, which is the next component of that. So typically when we work with different operators at this stage of their planning, we're talking through how you pull that vehicle operations information into the site-specific design. So we've developed some tools in our case that help understand when you pull in the block schedule, you've got sliding times for when vehicles are pulling in and out of the depot, and you have specific energy requirements per vehicle, so you can then map out what your energy requirements are at that point based on the operations. And then you take that information and you delve out your equipment needs, and then you could start to build out your budget on the utility side. Then you could start to look at how that equipment can fit into your existing facility. I'm sure everybody here in most cases is planning on electrifying at current yards or depots as opposed to purchasing new real estate, so you have to work within those type parameters. And then once you get to that piece, then that kind of gives you the conceptual idea of what you have both in the vehicle and the system design side, so you can then start to develop your overarching budget. And I think it's also important to mention that there is no one-size-fits-all for every operator. So if you're LA Metro or Foothill Transit, you're in a totally different situation in terms of your planning and budgeting than you might be if you're in Butte County, for example. So you have to all take that into context, but I think in general the message is if you start with the vehicle side first, you can start to build out your plan accordingly. Could you maybe advance the slide on your side? Thank you. So then when you get to, I guess while that's pulling up, when you get to the actual system design, which is where we start to help in terms of identifying your equipment requirements, again, it comes down to the modeling aspect of understanding your vehicle operations and then overlaying that into the site operations. So again, touching back into the sliding schedule, so understanding when the vehicles are pulling in and out and which vehicles will need what type of power as you manage that overnight. So we have a couple of tools we developed to help understand that. And sorry, there you go. And then slide 3. Yeah, please. Thank you. So again, it's using that vehicle operation to build out your entire master plan in terms of the system needs. So in our case, we're working with DC charging equipment. So if you're starting to plan around a system that's AC based, the math to build out your power requirements is relatively straightforward. So you might have a dedicated circuit to every parking space that you have, because when you're having conversion happening on board the vehicle, you have a fixed amount of capacity in each parking space. But when you're starting to look at DC charging, you then have the ability to centralize where your AC is coming in. So it's really important to identify, how many charging stations or AC feeds you really need, in a sense, to then support your entire fleet. Because the idea is that you then have remote dispensers that are located in different parking bays, and you're managing the DC capacity. So you're taking that profile, understanding your equipment needs from there, and then looking at how that overlays into the site specifics. So I'm going to reference a project that we're developing in the UK now, which will be 140 buses from one depot. I'll talk through some of the site specifics in just a second, but when you start to look at, okay, I know that I need, let's say, 30 charging stations and 140 dispensers to support that project, how do you make that work within the facility? And oftentimes you'll be looking at, developing an overhead type system, gantry sections to manage remote dispensers, because as you guys know, you have very limited space between all of the vehicles. So it's really hard from a cable management perspective, from a plug-in perspective, to really make all of that fit. And then to Damon's point as well, you might think that you have an existing transformer AC feed that's on one side of the property, but have you talked to the utility to understand if maybe there's an additional transformer you did not know about that they may be able to leverage in a different part of the yard? So it's about strategically mapping that throughout the depot. And again, it goes back to the genesis of understanding of vehicle operations to be able to build out that plan. And then I'll just briefly give you a quick, if you just eventually, next slide. Sure. Thank you. I'll just give you a quick overview in terms of what we're developing in the UK. So this is relatively similar to the plan that Roland and Damon were just reviewing for Foothill Transit. In this case, again, it's 140 vehicles from one depot. The challenge at this site is the structure was erected in 1870. So they've not only seen lots of technologies, but we're working with a very limited amount of space. And the color coding here is actually how we're mapping the DC capacity. So to touch back on the electrical infrastructure component, the utility operator, in that case is UKPN, they had an existing substation that was relatively close to the yard. So we actually got lucky in this case in terms of upgrading the primary service. But once we did the modeling to understand what that primary service level looks like and how much equipment we then need, we're able to strategically map out where we wanted to land the switchgear to then support the equipment needs. And obviously, you know, with DC charging equipment, there is a limitation in terms of how far you can have your charging station and then your remote dispensers. So the red rings that you see are really just maps of where the DC capacity is being mapped out within that yard. So to get into the operational piece then, the red section is the buses that will be electrified first in terms of the operations, not necessarily the infrastructure component. So the buses pull into the yard and then they pull into the front of the depot in that sense, so they're facing out to the east in this view. And we have front-loaded capacity to be able to charge those buses first. So what's interesting in this sense is this operator tenders for specific routes in the city. They have to also then have very specific buses that are tied to those routes. So they were limited in the sense that they don't just randomly assign vehicles the next morning. They have to have these vehicles parked in a very specific way to be able to get them out the next day. So in that sense, we front-loaded the capacity at the front here. And then where things really get interesting on the DC side is you see, if I were to have a graph, basically you'd have your power coming up as these buses are charged in the evening. So when they start coming in 6, 7, 8 p.m., you're hitting your peak load. And then we start to trickle out the DC capacity to the rest of the profile here. So then you start to get into mapping out on the blue section, the green section, and the yellow section as well. And then in terms of the site specifics, so how do you then build out your site layout and develop a budget for construction and installation? As I mentioned here, this building is almost over 140 years old. So what we looked at doing here in this case was using steel structures, so gantry sections that run across the top of the depot. We're relatively lucky in this case because they have an A-frame roof, so we had some space to work with up overhead. Another challenge that we had, though, is that each of the buses are double deckers, so they're a little taller than most buses. But in a sense, what we have here is when you tie it back to the red ring, you have little clusters of our charging stations. So you see the red block here, the blue block on the bottom, and then another red block over to the left. So those are little clusters or strategic points where we have switchgear and then converters that are sitting in areas that we're then mapping out on the DC side into these color-coded areas. So again, back on the gantry section, we then had remote dispensers that are tied to each parking space. And then as Roland mentioned, cable management becomes a question because you can't have an operator walking up a ladder to pull a cable down. So in this case here, we're actually looking at mechanized reels. So it's just a slip ring system that is authenticated with a point and click. We looked at several different ways of initiating the mechanized reel to bring the system down, but ultimately the operator photo point and click was probably the best way to do that. But then even when you bring the cable down, you have to respect, the bending radius on that cable. So you can't necessarily just rotate it at 90 degrees and plug it into the vehicle. And we're working with a special cable manufacturer because when the cable is fully coiled in the mechanized reel, you're still passing current through it. So you have to have, highly rated cable. It's specially designed. So I guess the overarching point is that, the technology is really improving to be able to handle electrification at this scale. But again, back to the genesis of the presentation here and, just building on the message that you've already heard, it's really important to start with your vehicle planning because we can't get to the point where we have a site plan like this until we really understand how you're planning to use those vehicles. And then we can say, okay, it makes sense for us to map out this amount of chargers to build the primary service according to this number, and then to manage the vehicle operations according to this configuration. So, and again, one size doesn't fit all. This is a very specific and unique depot, which is very different than most yards that I see today across California and in the country. So it's really just about making sure you're engaging the right stakeholders in the beginning, and oftentimes that, again, starts with the vehicle side. So, yeah. Thank you.
So, are these slides up, or we're sticking with today? Is this mic on? This is better? All right. So my name is Lars Peters. I'm with EVgo. Some of you may know me as the EV person in the city of San Francisco, where I was until 4 months ago, and did a bunch of work with Carbon, medium heavy duty, and ZEBs grants, and so forth. Let's see if this, could you forward the slides for me? Thank you. I find this panel kind of fascinating in the order we're going through here, because we all occupy and partially overlap different parts of the value chain here. And there could conceivably be projects where we're kind of, this whole train of people would be working together to support the transit agency getting a project done. So for that reason, I want to give you a tiny bit of background. Some of you are driving EVs, probably know EVgo more as, you know, the place at Whole Foods that you plug and charge your car at. So we are the largest DC fast charging provider in the US. Noted that Tesla has more chargers, we have more sites actually, which is, we have tons of those. Why is that relevant? And one more slide for me. Thanks. So, well, traditionally you saw these as kind of onesie, twosie chargers at a Whole Foods. These public depots nowadays are starting to be faster. So this is a picture of a 350 kW charger that we recently opened down in Bakersfield. As well as that, we're adding more chargers on those sites, sometimes 10, sometimes 20, 30, 40. Now, that starts to look very much like a depot, both from kind of an electrical infrastructure perspective, as well as kind of how you lay out all that and how you have to manage the power needs and power use of those sites. So where we grew from the public side starts to look very much from an electrical infrastructure perspective as the type of challenges that you as fleet owners have in your depots. And we actually call them charging depots now, or plazas, or there's various other names that folks come up with. If we go to the next slide. So I want to spend some time here. So if you look at these areas of the value chain that we'll work with, so what makes EVgo different is that we don't produce our own chargers, right? So we pick kind of whatever is needed from the bus or the OEM perspective, and the charging need, all the way from, in some cases, you're talking about rows of level 2s, maybe for vans that are only used for a part of the day that can get away with that. Some of it is now we see a resurgence of these kind of low-powered DC fast chargers, so DC fast chargers that are kind of in the 20 kilowatt range, and then go up to 350 or above 350, right? If you look at kind of, if you have some heavier buses, heavier duty cycles, and so with very large batteries, or things that are operated, let's say at airports or other areas that have transit systems that run all day, you can start having the need for 1 megawatt. People are talking about 2 megawatts per single charger. So what we do there is we take a vendor independent approach, look at what the OEM needs are. Companies like Lightning Systems, we are their preferred charging provider. Various other OEMs and fleet owners, figure out, similar to kind of the perspective, you start from kind of the demand side, figuring out what those electrical needs are, plug in the various bits and pieces of equipment. Do you want overhead charging? Is it okay to just plug something in? What are the type of vehicles? Do you have something smaller than a large transit bus? Do you have your non-revenue fleet? What are you doing with that? Are there some other vehicles that you want to counter into that equation? And then our role really is to kind of take the hassle and risk out of making sure that runs. So what are the things that are essential, right? You can't have this stuff fail. A lot of the charging infrastructure that's out there now, you're just not certain. I mean, we're getting a lot better as an industry. We're just not certain that if it fails, it's just immediately replaced, and it should almost never fail. how then do you manage that, not just as a fleet operations, but often you have other electricity needs? How do you balance against that? Do you want to have some battery backup? What do you do in case of a grid outage? That came up earlier. In case of a grid outage, we can work with partners to truck in like a generator that plugs in without any electrical work needed, just plugs into kind of a live plug right there to take over part of the power use. And I think what was brought up earlier, maybe that's not 100%, right? Maybe that's 50%, but then how do you make sure that that 50% goes to the vehicles you need and not used, to charge like, 10 of your buses and then it's done. So we combine all of that and provide what we call charging as a service. We provide and wrap that around into a solution where you can pay a flat monthly fee. That includes our operability assurances and SLA guarantees. Is it 99%? Do you want more than 99%? Well, you need to talk about redundancies in the system. It's going to cost a little more. But we can have standby, 24/7 people on site if something goes wrong. We can even wrap that around into a flat kilowatt hour price, right? So now you're starting to mimic something like your contracts with a fuel provider that you have in the past. And sometimes for budgetary reasons, that's a great way to talk to your city council or wherever you need those kind of budgets approved through and factor it into your operational cost in a predictable way. I do want to add to that something that came up around this kind of phasing of rollouts. I think if you look at it, it makes total sense at this point where the industry is to just look at every single vehicle or even piece of equipment. If you have a bunch of forklifts, something else, whatever is there, you can even look at building loads that are natural gas powered today and figure out, okay, what would be the theoretical kind of energy consumption as a system? Subtract how much solar you could potentially put on the roof, right? And then have that conversation with the utility. I fully agree, the utility, you need to have that conversation, not every year over again, now we decided to add, 10% or 100 new buses. You have to have that conversation up front, where are we going here? Port of Long Beach is a great example. If you add that all up, you're getting into numbers that are something that we haven't seen in the industry. It's amazing what something like that would look like if you include all the on-road and off-road equipment that they have. Similarly, for bus systems, you want to have that calculation, talk to utility, and then when we come in, we typically don't just plug in all the chargers from day one and let them sit there for 5 years while you buses trickle in. But there are things that you can do, right? You can at least size the transformers appropriately, or size the conduits appropriately, or run the conduits. A lot of what we're doing is running conduits and stubbing them out into the building, into the places where you need to be. In case we work with a utility program like the SCE program, and PG&E is about to come live with their version of Fleet Ready for Northern California as well. If you run into those programs, then our work is with the utility, and we pick it up and put the charger on top of the stubs. That's since we're talking about long-term investments, this is a very practical way to kind of reduce costs and operational risks for the company. So I'll leave it at that. I think I just want to say, I think we're kind of at the cusp of something that is going to be very material. And while we're busy kind of solving sometimes yesterday's problems on the charging side, I feel the real challenge is not those 10 buses, but doing the hundreds and getting to the 100% space. And we cannot remind everybody that we talk to, because maybe folks here agree, but whenever I step out of this room, folks are thinking about, can I get a one charger, one electric bus here, right? That's yesterday's problem. Our problem now is get to 100 plus, get to these megawatt scale projections and projects.
Well, I think all of the discussion here really demonstrated the importance of the planning side of these projects, from the vehicle side, the infrastructure. One of the things that I took away from this is the structural components, right? This is not just necessarily putting a charger out there. There's significant structure that may have to be in place to support these services. Any of you guys can answer this, but maybe start with Roland. You have 337 buses, 373 buses, sorry. For a smaller agency, that's operating, less than 100 buses, 50 buses, how would you suggest they start the process? Maybe they, don't have the ability to, or the funding to go out and hire a consultant to do this. What would you suggest?
So again, we're all in the same industry, all working in the transit industry. We have resources that we can share with everybody. So I would suggest that if you're working for, or if you're at a small transit agency and you don't have the funding to hire a consultant like some of the larger organizations do, you can reach out to those agencies who've done the study. You have all the information. You can call us. You can call Foothill Transit. I'm willing to share our experience. I'm willing to share the information that's been developed by our consultants. That's one way of going through it. Again, it's like what the other gentleman's mentioned. It's not, our solution does not fit everybody's solution. But you can gather some data and resources from what we've done and kind of apply it to your operations. I mean, as Norm Henkling said yesterday and other folks have said in the past, that electrifying your fleet, the easiest part of this project is buying a bus. You issue a bid to buy a bus, you'll have 4 or 5 OEMs trying to sell you a bus. The most important part is getting your infrastructure ready. And to get your infrastructure ready, it could take you a couple of years, because you have to go through design, you have to go through permitting, you have to issue a bid for contractors to do the work, you have to partner with your utilities, you also have to educate your stakeholders, let your board know what you're doing, what's involved in this whole project. It can take you 2 years or 3 years. But in the meantime, if you've started your pilot project with 2 buses, and your board has given you the direction to go 100% electric, we also have the ICT regulation where you need to meet 0 emissions by 2040. Once you have that pilot done and you realize that you need to move forward, get started. Start calling folks. You can also join ZEBRA, the Zero Emissions Bus Resource Allocation Group. This group has a lot of agencies that have done fleet electrification. We've got Sunline, Stockton, Foothill Transit. We have the experience and we can share that with you. And I think that's the best way to go. My recommendation.
Thank you. One other question, and then we'll take it out to the group for questions. But Kevin, for the project that you were discussing in the UK, what's the full schedule for that project, from pre-planning through when you expect construction to be complete and the buses to be there?
Yeah, that's a good question. So yeah, it does take a long time for a project of that size. So the first time that I went to that site was in January of last year, and my boss, Leo Dwyer, who some of you probably know, who came to us from Siemens, she started engagement with that operator 6 months before that. So we're now, a year and a half in, and we're just at the point where we're starting to move towards actual implementation. And then, so for the operator, they're looking at, a bus schedule for 140 vehicles. They're not going to obviously do all 140 at one time. They're going to start with 40 at first, and then roll and phase in according to that. And then on our side, we're working in a little bit of a different scenario there, because we're actually running the project as part of a consortium with companies like Siemens and a steel partner that we have there local to the UK. But really, it's, once you start building the steel gantry sections, and you've got to start manufacturing the charging equipment, et cetera. So at the end of the day, in terms of the planning, the development, and then the implementation, we're looking at probably 2.5 years to have a full system. And again, it'll be phased in, but it does take that long for a project of that size. And then on the flip side, if you look at some of the other smaller projects, if you're, working through a pilot, you may be able to do something in 12 months. So I wouldn't see that time schedule and use that as fear. It's almost just an acknowledgement that you have to, start moving early, I think. So.
Thanks. Jamie?
Thanks, Kylie. Jamie Levin from CT. I have a question for Damon and one for Kevin. What's SoCal Edison's budget for Roland's first 14 buses, and then looking at the entire facility, what kind of budget do you have to execute the power feed to the facility? And then for Kevin, what's the expected total energy in kilowatt hours that will be required for the UK project? Thank you.
So we don't have the budget for the full electrification yet. That's something that will be coming as we go along. For the pilot project that he's a part of, it was the priority review project, I believe was 4 transit agencies with about $1 million spend each. And I think we're hitting less than that.
What, 8 million you said?
No, 4 million for 4 transit agencies, so we're about $1 million. Because he's one of 4. There's 3 other transit agencies that we're working with as part of that pilot.
And then in terms of the total primary service required to support the project in the UK, I think it's just interesting to note the context. So the operator originally was looking at an AC system where the conversion was happening on board the vehicle, meaning that they were planning to have dedicated circuits run out to each of their parking spaces. And when they mapped out the primary service for that scenario, they were looking at close to 10 megawatts for 140 buses. As I mentioned before, we're looking at DC now, so we're taking conversion off the bus and having that happen within our power blocks or converters, if you will, and then managing or shifting the capacity on the DC side over the evening. So just leveraging the downtime that the vehicles have. So in that case, we're looking at just under 5 megawatts to support that fleet.
So 10 megawatts of connected load, but managing it down to 5. That's pretty much what you're saying, right?
No.
Oh, really?
So in a sense, what we're doing, and that's where the modeling and the optimization comes into play, because what we're doing is we're leveraging the time that the vehicle is sitting there, so in its sliding schedule for the entire fleet. So we don't necessarily have to have a dedicated circuit for every vehicle. What we're doing is we have a dedicated circuit for maybe 4 vehicles and then sharing the power across those. And that's why, and going back to the modeling, so the next thing you're probably thinking is, well, how do you know that you can get it done with 5 megawatts? So when we looked at the modeling and analysis, we did time-lapse surveys in the yard to understand, exactly, when the bus gets back in, do you have 25 or is it 40 minutes before you take it through wash, revenue collection, and park it? So we had to look at all the meticulous details in terms of that. And we found that we could probably have gotten away with doing that entire fleet with just under 2 megawatts. In a fully optimized system, but then you have to do the stress testing. So what happens if, half of your fleet, gets delayed, jammed up in traffic, there's a, weather anomaly, something in the city, you have to be able to account for that. So we ended up pushing that back up to a more optimized level of just under 5 megawatts. Yeah.
Hi, Ray Pingle, Sierra Club. This question is for Kevin, and Lars might also want to add some comments. So when you're designing the system, and especially a very tightly, well planned out, meticulously planned project like the UK, a couple of objectives are to minimize the amount of electrical infrastructure that has to come on site, to minimize
Everyone should just exit this building calmly, taking the stairs. We'll have people directing you outside.
It was just getting something.
No, let's just.
Attention all building occupants. Attention all building occupants. An alarm has sounded on the first floor, the basement, first floor, and the second floor. Please practice your relocation procedures. All the floors stand by for the update announcement. I repeat, attention all building occupants. An alarm has sounded on the first floor, basement, first floor, and second floor. Please continue with your relocation procedures. All the floors, Attention all building occupants. Attention all building occupants. A fire alarm sounded on the first floor. Fire department engineering has given the all clear. Please return to your designated work areas. I repeat, attention all building occupants. Attention all building occupants. A fire alarm sounded on the basement, first and second floor. The fire department and engineering have given the all clear. Please return to your designated work areas.
no problem. Yeah, I was trying to do a little better than I did yesterday. Well, what happened too, this is my honestly first time, but this system right here, when people are sending me PowerPoints or PDFs, and then I have to go to this main slide. No problem. Due to time, I mean, let's see. 9:51. They might, yeah, just cut it. Well, then again, you know, we have a break, so maybe. Let me ask, do you want to cut into the break 5 minutes?
No,
and then more questions?
no. Let's continue for another 10 minutes. We'll cut the break short.
Okay, so yeah, we are going to ask.
Or are you thinking to just give people a break right now and then come back early? People are not going to come back early.
We got 4 minutes until this is actually over.
Okay. Yes, yes, please. So if everyone can take your seat, please, we are going to continue. And we're just going to cut the break short. What I forgot to mention this morning is that in the case of a fire drill or a real fire, do not grab your bags with you or come back with your luggage unless you truly need your medicines with you. Yes. Yes. All clear? Not yet. Okay, so we'll continue our questions, and we are going to cut our break short, so when it's break time, we'll let everybody know. Thanks.
Okay, we'll go ahead and, yep.
Hi, I hope I didn't start that problem. Ray Pingle, Sierra Club. So this question is for Kevin and maybe Lars as well. So as you're designing this very tightly designed system to minimize cost and everything, that's great. But things are going to change. You know, routes will change. There'll be more buses. They may have to change their blocks. So when they comes in, batteries are going to get bigger and so on. So how do you, you know, kind of cost effectively design in some flexibility as you plan this so you don't box yourself into a corner?
Yeah, absolutely. I think that's a great question. So I think there's two ways to go about that, and I think it goes back to the modeling piece as well. So you can't necessarily optimize yourself into a position that you're pigeonholed in. So you can't say, hey, I need 5 megawatts if you think that your service is going to adjust, or if you think you're going to be adding additional vehicles with more battery capacity in the near future. You can't do that. So you have to be able to add in some of that contingency into your modeling plans. And then from the infrastructure perspective, you have to be able to map out the conduit and wire back to places where you can tap off and have flexibility to then move things around if you have to. But I think also you have to understand that once you're building out these sites, for example, the project in the UK, we'll have structural frames, like steel frames that are running across the top of that yard. So in 5 years, we can't necessarily just take out a frame or a gantry section and move that around. So we have to be able to, again, going back to the planning on the vehicle side, understanding what the whole process looks like, what the whole plan looks like, so we can then map that contingency in and then allow for some flexibility in the yard as things move forward.
Yeah, and on our side, this is a similar answer, and I'm trying to give a little bit of a different flavor of it. So I was just saying this actually, there's two things to think about. One is kind of what is the individual start speed that a vehicle can accommodate, right? And you want to at least size your conduits, if there is any conduits running or whatever kind of permanent structures that are in there. So not your wiring, but your conduits. it's fairly cheap to oversize those and make them ready for, let's say, now you have a bus that can accommodate 100 kW, but you may replace it to a 300 kW and run a bus maybe you have some buses that you want to run 18 hours a day, and that's something you do with your next generation. So oversizing that conduit is a fairly cheap investment. It's the labor to actually place it there. So I would say that's one thing. Then on your total facility side, you make a different calculation. Your calculation there is more around what's the size of my main transformer or any number of transformers that you may have. And that's more thinking about how many buses will I have in the future, how maybe some growth, maybe some new lines, longer lines, extension of hours and so forth, and you create enough headroom there. And the difference between those two things is like what I always stress is you want to almost do those things a little independently. So yes, you oversize your individual endpoints so you can accommodate and charge any vehicle really fast if you need to, but don't make the mistake to say, now I have a 200 kilowatt charger or pipe there and I buy 200 buses, and that means 200 times 200 should be my main transformer. And it's surprisingly often that projects kind of make that assumption or a variety of that. Right? Like you need to think about storage potentially to reduce that. That's the part on the building infrastructure side, but absolutely oversize those individual pipes. Like even if you think you can get away with charging your bus in 8 hours and you just make it, plan for the snowy day with tons of traffic or a bus that breaks down and comes back completely empty, plan for that next bus that you may buy that has an even bigger battery capacity, plan for buses that you run 20 hours a day. Whatever is applicable in your territory. And just to be practical on this, we do this today, and actually the utilities are doing this today, where we go in the public side, there's only very few cars that can take 150 kW, just light-duty vehicles on the road. What we do, the transformer is sized to support it, all the wiring is sized to support it, or at least the conduit is sized to support it. The actual chargers may just be an 80 kW unit today, and we can just come in and swap those out 5 years from now.
Good, thanks.
All right, good morning. John Drayton. I have questions for Damon about the Charge Ready program. For a couple questions, so. First question is, does it get charged or amortized back with the ratepayer, Foothill Transit, or is that program going back to ratepayers in general? Second, you said that you're going to do all the general contracting work. Is that Edison personnel coming on? Are you geared up to do all the 100 or so transit operation locations that are in your service area? And do you know if like PG&E and others are going to match your program?
First one, who's paying for it? Right? That's your first question. Who's paying for it? So CPUC authorized the spending from ratepayers for the programs. So ratepayers will be paying for the infrastructure first, but the intent is that those electrons are going to come, and that will be spread across all the ratepayers. So ratepayers' costs will hopefully be pushed down because there's more electrons coming in and being built. That's one. Two was. So the Charge Ready Transit or Charge Ready Transport program, where transit's a part of it, it's authorized spend of $343 million over 852 sites. That's an average of 10, with about 8,500 vehicles, or an average 10 per vehicle. Some of those sites are going to have more like 100, like transit agencies. So we're going to accommodate for that. We have ramped up a team. Not only my role is changing and delivering these programs to the assigned customers, but in Edison's territory, the customers have assigned reps first, and we go out and bring these programs to them, and then we're developing the construction management team. Right now, it's Simon Horton, but there's 4 or 5 other Simon Hortmans that are hired right now that he's training. So they'll be the ones delivering the actual construction aspect of the programs. Edison personnel will do as much work as possible in terms of pulling the equipment, but once again, we're not civil contractors, so we're going to contract that type of work out. And then we also don't do work on the customer side. So we'll be contracting that work out most likely also. That team is being built as we speak in terms of the preferred contractors list and so on, and getting that work done. We also do the design, so we're contracting that work out also for the customer side. The Edison side, we're good at that, and we'll do the Edison side of the design. Was there one more question? Yes. So the investor-owned utilities were tasked under Senate Bill 350, so San Diego Gas and Electric, PG&E, and Southern California Edison, to come up with programs to stimulate the market. They have programs. I know there's presentations happening later on them. Do they mimic Edison's? I'm not sure.
I think we've got time for one more question.
It's okay, I can hear you.
I was just wondering, thank you. And I've heard from like LA Metro and others that they're planning around maybe 3.5 kilowatt hours per mile. So I'm just wondering if you're planning around the 2, or if that's just kind of what you see as your normal average.
So when I mentioned 2 kilowatt hours per mile, it's based on our current experience. So on our Route 291, where we have fast charge buses, our average energy efficiency is 2.12. On our 40-foot extended range buses, we've done some testing on our line 280, and we're about 1.8, 1.9. We also tested a 35-foot extended range bus on a service that we're going to take over for one of our member cities, and we're getting between 1.8 and 2.3, depending on the topography. So I'm just averaging it out 2.0 just to figure out how much energy you're going to need to electrify your fleet. We're looking at, yesterday Kevin mentioned that we're acquiring two battery electric double-deck buses at the end of this year. We will deploy that on our commuter line Silver Street going to downtown LA from Montclair. Initial studies from the engineers that's designing the bus, since it's a double deck with 80 passenger seated capacity, they're looking at maybe 3.1 to 3.3 kilowatts per mile energy efficiency. So it depends. I mean, those numbers can change depending on your route. There's so many, people talk about driver efficiency that affects the energy efficiency of the bus. I mean, you still got to look at how many stops on that route are you stopping? How many times do you pick up ADA passengers, because you have to deploy your ADA ramp. Your weather has an impact on that as well, and then topography. And you need to, if you get that efficiency, you need to give it a little bit of a leeway, because sometimes you'll have an accident on the road and your bus might get stuck in traffic for another half hour, and that idling takes energy out of your battery as well. So be conservative as far as looking at your routes and how much energy you think you're going to need to electrify those routes. You're welcome.
Well, thanks to everyone on the panel today. Really appreciate it. Really good discussion. If there's anybody has questions afterward, I know we were interrupted in the middle. Please just come up, talk to us, and we can answer whatever questions you may have.